Hello and welcome, everyone. Thank you so much for joining us today for our weekly OCI Deep Dive. For anyone who might be new to these events, we're hosted on Cloud Customer Connect, which is our Oracle community forum for end users. I'll be sharing some resources back to those forums through the presentation today. And if you're not already a member, we invite you to create a free account, join in discussions, post questions, and look for some upcoming events. My name is Kenna Kettrick. I'm a program manager with the OCI go-to-market team. And today we're joined by Beda Hammerschmidt, Senior Director of Product Management, and Roger Ford, a Principal Product Manager here at OCI, for a demo-filled dive into MongoDB. That is all for me. I'm going to hand it over to you, Beda. Take it away.
Yes, thank you, Kenna. Good morning, everyone. At least good morning if you're on the west coast of the US. Otherwise, good day. So we're going to talk a bit today about a new API. It's called the Oracle Database API. And it's an API that is, as for now, available on the Oracle Autonomous Database family. So you can use it for the autonomous transaction processing and data warehouse. So it is an entry or a gateway to get the rich ecosystem of Oracle Database on MongoDB collections. We're going to explain in a second how this works. But it's also available for the autonomous JSON database, which is like an entry-level service. It's priced much lower than the other autonomous databases, but it kind of gets the same set of capabilities. It's built on the same technical infrastructure. It's also a full Oracle database. It is just primarily for JSON use cases, and this is exactly what we're gonna look into today. So what it gives you is it gives you access to an enterprise, the Oracle Enterprise application using MongoDB's tools and drivers. So you can take a MongoDB application, for example, or a framework or a tool, and you connect it to the Oracle database, to the Oracle Autonomous Database, as if it was a MongoDB server. And this allows you that a developer can continue to use or to develop the way they develop with MongoDB. They kind of stay within their comfort zone. They can reapply their skills. And at the same time, we store the MongoDB JSON data or BSON data in a relational table in a JSON column. So this happens fully transparently. It behaves really like a MongoDB collection. But now, because it's stored in Oracle database, it allows you to run SQL over the same data or to query your data alongside other data. Let's say you can join JSON data with relational data or XML or spatial. So it's really a gateway to get to Oracle's powerful database capabilities, analytical, for example, machine learning. And it's also possible to do it the other way around. So you can, for example, expose relational data or reports or query results as read-only MongoDB collections. So for example, if you have an existing relational application and you want to do, let's say, some modernization, microservices on top of this existing data, you could create a view or even like a query on that view, and you expose that as a collection and you map that to a MongoDB collection, and then you can query it. So a little history lesson here. What we've seen in the past as a repeating pattern is that there are new data models popping up on average once a decade. And we've seen this since the 80s about. So like pre-relational times, there was IMS, which actually is also a hierarchical data format similar to JSON. And then there was this big innovation, which is very, very old, which is the relational database. And since then, what happened was that new data models popped up, like objects or XML, JSON, graph. And each of these data models was accompanied by special databases that would just support this one data model. So when I joined Oracle, it was the big time of XML, and we had a lot of companies that provided dedicated or XML-only databases. Nobody speaks really about these anymore, and the history moves forward. New data models occur because they have benefits over existing data models. This obviously leads to the creation of specialized database, but what's happening since many decades is that the relational model is just powerful enough to subsume these new data models. So several decades ago, we added support for object types. Then maybe 20 years ago, it was XML type, and all these XML capabilities were added to relational databases. Since about 10 years or 8 years, so it is JSON. So we actually wrote an open standard on how to process JSON data using SQL. And we see a lot of other database companies follow our lead here. The same is happening with Graph. And the benefit really is that once you have support for these additional data types in a relational databases, is that you're not limited to just one data model. So what this means in the case of JSON is you can join your JSON data with relational data, or you can generate JSON data from relational data, and you have a full flexibility of these data models. So we call this the converged database. Another term is multi-model database. We have this since about 2013, 2014 for JSON. And what we added is a way to now make this technical stack MongoDB compatible, in the sense that you can view your JSON data as if it was a MongoDB collection, while at the same time, it is stored the same way in the database, such that you can query it with relational data. And we're going to show this in a second in a demo, so we're not only doing slides today. So if we talk about this Mongo API, before we go into the demo, you may ask, well, how compatible is it? What we found out is that a typical application requires minimal amount of code changes. This is what we're going to see in the demo in a second. We do support transactions, and MongoDB transactions are mapped to Oracle transactions. We also support the new way of load balanced connections on our cloud service. This is makes for efficiency reasons, this is what we recommend. Then we can actually move your queries and database operations to different nodes, and we scale much better. So all that compatibility is there, but there are some restrictions. Some are intentional and some are temporary. And one intentional restriction is that we do not support the MongoDB's way of managing users and roles. Instead, we use the Oracle, like there are Oracle users, there are Oracle rows, and there are certain ways that these behave. And the Oracle security features heavily make use of this, and we just find that it's easier to manage if there is one way to handle users and roles in your database. So this is something to keep in mind, that your Oracle or your MongoDB users would map to Oracle users, and certain roles are different. I don't think this is a huge limitation unless your application makes heavily use of MongoDB's different roles, etc. So you would have to find like a matching roles, etc. Another limitation we have at the moment is that we don't have much support for the MongoDB aggregation pipeline. So our message has always been that you can run SQL for your analytical queries, or if you want to do aggregations. So you do have full support to do all these operations using SQL. And actually, even MongoDB appears to acknowledge that there is a need for SQL. They recently added a SQL stage in their aggregation pipeline. But at the same time, to increase our compatibility, we are looking to support more features or more stages in the MongoDB aggregation pipeline in the future. Yeah, and with this, this was the introduction. So let's look at a little demo here. So again, it is we're talking about an API here. An API means that you can interact with the database from different drivers. So it's not like a brand new kind of technology or new SQL-ish thing. It's really like a gateway. So, and the best way I think to show the capabilities is to do a demo. And the demo that I will show, there is a second demo that Roger will be showing in a couple minutes. So my demo is basically an application, and we take like a sample application that we found on GitHub. So we did not create our own application to make sure that we only show what we can. No, we took like a sample application, and it's from the MERN stack. And MERN means MongoDB, Express, React, and Node. So it's a JavaScript application. So we will install it and run it first on the real MongoDB. And then we will move the data to our Oracle Autonomous Database, and we will migrate the application to run on Oracle. That will actually just be replacing the connect string. So this is really minimal code change to run the application on Oracle. And then I will show that now you can have really SQL access to your MongoDB applications. Okay, so now with this, let's get the demo started. And this is a live demo. It's not a canned one, so things may go bad. I apologize in advance if this happens. And what I have prepared is so if we look at this, I'm connecting now to actually a MongoDB database, and we see there is like a schema or a user. It's called MERN demo. We will use this, and we will, from time to time, we will go back here just to see that there are the real changes happening in the database. And I have a similar window for Oracle here. So let's get started. What we're going to do is we're going to migrate this MERN stack application. So this is from it's called ProShop MERN. It's a shopping or a sales application. And this is a GitHub project, and we will just now clone this GitHub project. Let me move these windows side by side, and I'm tilting my head to the left because this is where I have my instructions. And what we're going to do is I'm using Git here to clone the repository. So I'm really starting from scratch. So you will see that I'm pulling down this application here, and I need to, the change I have to make is to provide my connect information to the database. So you see here, this is an environment file, and what I have here is a connect string to a MongoDB database, and this one is commented out. This is the Oracle database, and I will make the migration will basically mean I will comment out, or I will add a comment to MongoDB and comment out the other one, and that is the whole migration step. But with this, let me go on and install the application, and this will take a while. And I think we can run our second poll now while this is installing. So this is downloading a couple megabytes, actually many megabytes from Git to start this project. And I have another poll up here. Thank you. Thanks, Kenna. I can sip a tea. Yes, and what we're going to do is, like, once we migrate, I already have these pages up. This is our autonomous JSON. By the way, everything I'm showing, I'm doing on the always free tier. So I don't have really like some big Oracle account here. I sign up with my personal email, and I've got an Oracle Autonomous Database free tier account. I'm using 2 databases, and this is our UI. And you see, this is the collections I have here. And you see there is a collection test. That is one we're not using. And you will see later, if I refresh this, that during the migration, we have new collections there. So let's see what's happening here. Okay. It installed it, and the next step is to load the data. So this is faster now, and this will just install some sample data. And now if I refresh this here, you will see that in addition to our test application, we should have 2 additional applications. Why is that not the case? Interesting. Just 1 second. What do we do now, Roger? Do you want to start your time and I try to fix this? I mean, your demo is independent of mine, so I apologize for that. It just shows it's a live demo. It may have to do with a connect string, so maybe you could, I turn off my camera and try to fix it.
So I'm going to talk a little bit about autonomous JSON database and give a demo of autonomous JSON and the MongoDB API. So autonomous JSON database is part of Oracle's autonomous database cloud service, and it's aimed at JSON developers, people who want a simple way of working with data using JSON documents. It's a subset of the full autonomous transaction processing, and it's only subsetted in as much as it limits the amount of non-JSON data. Otherwise, it has all of the capabilities of autonomous transaction processing. It's very flexible and fast. It uses a native JSON storage type for storing documents within the database, and it provides you with simple document APIs so that you don't need to know SQL. And you have a choice between the MongoDB API and Oracle's own Soda API. And you can use that from various different programming languages, from the command line, or from REST. So you get all the benefits that you'd expect from a simple NoSQL document store. It's fully elastic. You can scale up and down very easily. You've got very fast access to your data. We have single-digit millisecond access for reads and writes. It's highly available, and it's low priced. It's actually priced at the bring your own license level for that we have for autonomous transaction processing, although you don't need a license. So it's particularly suited for customers who don't have existing Oracle licenses they need to use on the cloud. So you get what you'd expect here. Everybody who provides document databases these days provides a MongoDB API, but we provide a whole lot more than that as well. You get all the benefits of the autonomous database. You get full SQL support over that same document JSON data. You get full ACID transactions, all the advanced capabilities of the database, such as the security, the best of breed Apex low code application development. And then if you ever outgrow autonomous JSON, you need to add more than 20 gigabytes of non-JSON data, and it's a one-click expansion to the full ATB capabilities. So a couple of ways of dealing. Could you try again? Excuse me. A couple of ways of dealing with your data. You can use the cloud tools provided by Oracle, and we'll see those in a minute, or you can use Mongo tools such as Mongo Compass. So your data is stored in the Oracle database, as I've said. Data is stored in Oracle tables. But if you're a developer using the document APIs, you don't need to know anything about those tables or SQLs. You can use MongoDB API or Oracle's own Soda API. But at the same time, on the right-hand side there, we have SQL access to the same data. So if you want to do advanced reports, then you've got all the power of SQL across that same data as you were working with using the MongoDB APIs. We'll see that in the demo in a minute. We can go between JSON and relational data in either direction. So here's a couple of simple examples. We can extract data from JSON data. Here we've got a column called data, which stores our JSON documents. And one of the data items within the JSON is PO number, purchase order number. And so I'm able to select this in SQL using this, what we call dot notation, saying that I want to fetch all the JSON documents where purchase order number within those documents is 1600. And to go the other way, we can construct JSON documents very easily from relational tables. In this case, we're using the JSON object function to concatenate first and last names columns from the database and produce a JSON document with just name and then the customer's full name in it. Okay, so because it's based on autonomous database, you get all the extra features available in autonomous, such as spatial, machine learning, full PL SQL access with JSON extensions in that PL SQL, virtual private database, and many more features that Oracle provides. So that's it. It's modern document-centric development, but with all the capabilities of the Oracle database, and it's based on autonomous. Okay, so let's go into a demo from there. So here I am in OCI, Oracle Cloud, and if I want to create a autonomous JSON database, it's very straightforward. go to Oracle database here, and then I can choose autonomous JSON database, create database here. And I give it a little bit of information, the name of the database. It's already pre-selected JSON as the workload type. I can do the sizing or just stick with always free, which gives me 1 CPU, 0.2 terabytes of storage, I believe. I give it a password for the admin user. One point that you will need to know if you're doing this for yourself, in order to use the MongoDB API, you must set a ACL to access the database. If you set it to secure access from everywhere, it will not allow the MongoDB API. So I can just add my IP address there, and that will allow access from here, or I can add a list of IP addresses, whatever I need. And that's pretty much it. I'd click autonomous database here, and it would then create that database. But rather than sitting around waiting for that, it only takes about a minute to create. But we have some that we've already created here. So let's have a look at this Roger London database. I'm going to go into that. And if I go to Service Console and then Development, now down here, you'll see the MongoDB API. For most cases, you would use this first one, port 27017. Occasionally, some clients don't support load balancing, in which case you use this 27016. But this is the URL I need to contact my autonomous database using Mongo Tools. So let's try that out. I'm on VM here, and I can connect to autonomous database via the Mongo shell, and that is the URL copied from that page we were just looking at. I've made a slight change here just to move the username and password outside so I don't reveal the password here. Password is in a variable. And that will now connect me to autonomous database. Now, stress, this is the standard Mongo shell tool. We haven't provided a special version of the tool or anything like that. It's the perfectly ordinary Mongo shell tool downloaded from Mongo, but it's now connected to the autonomous database. And as far as the tool is concerned, it doesn't know that. It thinks it's just connected to a normal MongoDB database. So I can create a collection here, simple enough. And if I show collections, we can see that there. Then
Here's what I found.
So I can add some data to that. So we're going to insert a new document to our EMP collection. This is obviously just an employee record. Let's try a second one. And this one, you note, has an extra field in it, email, which the previous one doesn't. And of course, being JSON, we have schema flexibility. You can change the pattern of documents. They don't all need to follow the same form at all. Just insert a third one of those. And so that's now 3 documents in there. Let's do a query. So this is query by example. So this is the way you normally query document databases. You just provide a fragment of JSON. In this case, we're looking for any documents where name is Miller. That comes up with that one document. Again, this is standard Mongo syntax, but running against autonomous database. Query by example can be more complicated than that. We can do a range search. So here we're saying find all the employees where the salary is greater than 50,000. So that brings back our 2 programmers and not our intern. Okay, so, oh yeah, and we can do an update. So that would be that one. So we're now adding an email address to Miller. Miller doesn't have an email address. So by saying update 1, we provide a query to find the documents to be updated, and then we say set the email address to be miller@example.com. That tells us that that is now updated. And if I search for Miller again, we see that the email is there. Okay, let's go back to Autonomous Database, and I'm going to go to Database Actions. Now here we've got a couple of things of interest. We have JSON and SQL. Let's look at JSON first. So this is a GUI view over our data, and there's the collection that we just created from Mongo, and it's done a search for us, and it's found those 3 documents, Blake, Smith, and Miller. Now I can do queries here, similar to MongoDB. I would run, where are we? Find records where job is programmer. Yep, and that finds 2 of them, so we don't find the intern this time. Okay, so that's queries against the collection. And of course, we can create new collections from here. We can create documents within collections. We can edit the documents here or delete them or whatever. Now, let's go back to Database Actions again and look at the SQL view of the same data. So this is SQL. This is where you'd normally be working with your relational data. And we'll notice that there's an emp table here. And this was created automatically when we created the Mongo collection. And we can see that it has, the emp table has various different fields in it, housekeeping fields, plus data, which is where our actual JSON data is stored. So let's do a search on that. I'm going to just do a select star from emp. If I run that, then we will see that there are 3 rows because we inserted 3 documents in our collection. So 1 document is represented by 1 row in the table. Now, the data, which is what we're really interested in, is actually a blob. So the SQL view doesn't show this very well. If we want to know what's in the JSON, then we have to use something called JSON serialize. And by saying JSON serialize e.data, then that will show us the JSON content of the data. Now, that's great. We can see that JSON that we inserted from Mongo, but we can't really do much with this. It's just a blob of JSON. So, I mean, if we're passing that to some other program, that might be sufficient. But what we really want to do is interact with individual elements of this JSON. And that's very easy to do as well. So we'll do that with what we call the simple dot notation. So emp is our table, given it an alias e, and we can just say e.data.name, and that will extract the name field from the JSON. The same with all the other ones. So now that looks exactly like a normal SQL query, and the data is fetched as though it was columns. Blake doesn't have an email address, so we just get a null value from that record. Now, these look like columns, and they can be treated exactly like any other Oracle column. For example, I can do a simple aggregation query to find the average salary by job. Let's run that, and we can see that the intern, the average salary, there's only one of them, is 30,000, and programmer, the average salary is 65,000. Okay, so that's an aggregation of data from the JSON documents. Now let's, oh yes, sorry. Let's go and look at some real data. So, bear with me a second. We have some data from City Bike. City Bike is a bicycle rental service in New York City, and they very nicely provide data about bikes available in the various locations around the city. And we have some of that data, and we can, it's in JSON format, so we can load it into the database. If I have a look here, we've got station information, which tells us the location, the rental locations around the city, and station status, which tells us the number of bikes available at various time periods. So I can load that in using another standard Mongo utility, Mongo import. So I'm running Mongo import, providing username and password, the file name that we want to load, and then the Mongo URL. So that's now loading into the autonomous database, and same for the station status. So that's now loaded those two collections. And if I go back to JSON, then refresh that, we'll find that we've now got 3 collections in here. And again, in SQL, we've got 3 tables here. Now, oh yeah, sorry, one more thing. In Mongo shell, let's just have a look. Let's do show collections, and we can see that we've got those 3 collections. And let's just have a look at one item in here, station ID 497. This is the station at East 17th Street and Broadway, and we're going to use that a little bit later. So back to SQL, and we're going to create something called a data guide. And this is something that allows us to look into the JSON in a database and examine the contents of that JSON and find the pattern or schema of those JSON documents. And we can use that to automatically create views. And we're going to create 2 views from the data guide, station status view and station information view, over those 2 collections. So that will be SQL views over the collections that we created through MongoDB. So let's run that. And that's done that. That's created our 2 views. If we go to views over here, we can see that we've got station information view and station status views. So let's do a query from those. So this finds the minimum and maximum bikes available from each station. So we're joining 2 JSON collections here. Actually, it's a subquery rather than a join, but same thing. So this is fetching the data out of 2 different collections and running a single query against them. And that will then produce the output of the station ID, minimum, maximum, and average number of bikes available from those different stations. Now let's just turn that whole query into another view. So we're now going to create a view station stats to simplify this lot. Run that. Actually, no, that's just run the select again. Let's highlight the whole thing. And that's now created that view. If I go over here, we can now see that we have a station stats view as well, with the station ID, name, min, max, and average numbers of bikes available in each of those views. So that makes for simple queries. I can just say, get the maximum number of bikes available from each station. So name and match, and that'll give us a view of the maximum number of bikes available at any time. That's great, but it's not particularly easy to visualize, but we're in autonomous database here. So we can very easily create a chart of that. Let's create a new chart and we'll call it max bikes. Description is max bikes by station, and it's not protected. Click next, and then we're going to put in that same query that we just used. So it's a query across that station stats view. And we want that as a bar chart. So all we need to do, click create down here, and then I can view the chart here, and that gives us a nice visual representation of the maximum number of bikes available from each station. Now remember our East 17th Street and Broadway that we looked at earlier? Well, let's go and make an update to that from MongoDB. So I need to be, oh, I am in Mongo Shell, sorry. So we will just enter some new data here. So this is adding a new data point. So it's a new time effectively. And we're going to say that 200 bikes are available in station 497, which we saw before was East 17th Street and Broadway. That's done that. And if I go back to Oracle and refresh my graph, we can immediately see that now we've got 200 bikes on East 17th and Broadway. So this is real-time updates. We can update the data from Mongo, but we're viewing it from Oracle. And that's the power. You get all the capabilities of Oracle SQL for querying, but the simple API of Mongo for working with that data. That's all I have to show. How is your demo, Beda? Is it working?
It's up again, yes. I officially earned a stupid badge today.
Okay.
And I can explain what happens. I was about to show that how you connect the connect strings, but I forgot to save it. And as a consequence, the application wouldn't know where to store it. Now I just saved it, I reran it. You see the data got imported, and now I refreshed it, and we see that 2 more collections have been created. You see my screen, right? I'm sharing?
Yep.
Good, good. So we see that there are these products. Now this is really a MongoDB Atlas here. Now let's run the application. Let's see how the demo continues. So now we are running. So this was the error 500 we got. You see it's already reloading, and we should see that our demo application is running. So we do have some items we want to sell here. So I stop right here. Now let's migrate this. So what I do is I stop this application again, and we're going to migrate it to an Oracle Autonomous Database. So if you see I'm refreshing this here and I'm looking at JSON collections, you would see that there is our test collection, but products and users are not created yet. And we're going to create them by migrating this data using very simple tools. So we're going to use, let me find the right command. So we will just export the data. So Roger has shown commands like Mongo shell and Mongo import, I believe. We're going to use Mongo dump here. So now with Mongo dump, I'm reading the data from MongoDB Atlas, and I run the similar command to do an import. So it's called Mongo restore, but now it is connecting here to an Oracle database. Hopefully this succeeds here. And now if I refresh, then we hopefully see that, yeah, we see products been created. And I can even, from this UI here, I can use MongoDB's own way of querying data. So for example, if I use this, we call it query by example. I think MongoDB calls this MQB or something like this. So I can query all the products by where the brand is Apple. So this migrated the data. The data is now sitting in Oracle. What do we have to do to also migrate the application itself? Well, I said earlier, all we're going to do is we comment out the connect string to Oracle, and we uncomment the one to Frankfurt, the Oracle one. And don't forget to save. And now if I restart the application, we should now be connected to Oracle. So let's see if this reloads. We see it's reloading. I mean, if it works, it would look exactly the same. It does here, but what we can do now, actually there is, I also have MongoDB's own Compass tool. So let's refresh here. This one is now connected to Oracle again. So now I can see the same collections. Let's look into products. I can even use the Mongo tool to query it. So I can say brand Apple, the same query here. So it's really easy for a user who's familiar with the way of interacting with MongoDB tools to continue to work as is. And we see the same query result that we had on our Oracle page. Let's make a change here. Let's say you moved stuff to Oracle. Let's lower the price. So we want to change the price to, let's say, to $69. We lower it by $20. So now if I refresh this page, I would hopefully see, yeah, it's $69 now. If I go to, if I refresh the query here, so we had the 89 was the Bluetooth headphones. If I run the query again, we should be seeing that it's now 69. And just if we look at MongoDB Compass itself, so this is what I've not changed. This is where it's the Atlas instance. And if I, let me just copy this query here, and that should still be at $89. There it is, $89, because we haven't changed it in Atlas. Good, so this showed basically the next steps. I moved the data using MongoDB's import-export tools. I migrated the application by reconnecting it. So this application really works just by connecting to Oracle. There may be, we said earlier, there may be other applications that make use of the aggregation pipeline. So for those, they would not, it would be more than just replacing a connect string. But now let's look at the added value. Since you moved this to Oracle, what does it really offer you? So what we've shown here is what we call the JSON page, and this is a JSON view on collections. So you saw the product collection, the user collections, very similar to MongoDB Compass. And this is the typical way that a MongoDB developer works with the data. They view the data as collections of JSON documents. But each of these collections is actually backed by a table. So if I go to our SQL view of the data and I refresh, then I see that there are also now tables called product and users. And Roger already has shown this a bit. I just repeat it. So these tables that are backing the collections, they have a column for the ID, a bit of metadata when data got when an object got created or when it was updated and what version is it. And then there is a data field, and this is where the JSON resides in. And this I can now query like any other table with SQL. So now I can say, well, I have some analytical queries. Well, the things that I will demo are rather simple. So here I just want to extract the name and the price from all the products where the brand is Apple. So you see I'm just using regular SQL and I get a relational result back. So now this is really easy for a person more familiar with SQL to operate on the very same data. Or I can say, well, if it's really analytical, I may want to do some aggregation functions, the average price per brand. And you could also join this. So this is really a full Oracle database. You can now add joins, you can do transactions, you can anything that's possible with Oracle SQL is now also possible on JSON. So this is not like a JSON specialized database at all. It's the full Oracle database with very strong support for JSON data. This is really the added benefit. We believe it's the ability to have both NoSQL access to the data using collections like MongoDB compatible collections or SOTA collections, and at the same time being able to work with SQL over the very same data. I could also update it. I could have PL SQL triggers, etc. It's the entire ecosystem that is now available. Yeah, and with this, I'm happy that I was able to complete the demo. It was just that I forgot to save the file. It was too early for me. Sorry for that. Do we have any? I already answered one question.
Yeah, we have one question.
Yeah.
The backend is built with Node Oracle DB. No, it's not, is it? It's built using the Node libraries for MongoDB.
Yes. Yeah. So the way to think about this Mongo API, let me maybe, do I have a good slide here to share? So no, I don't. Let me try to explain it. What's happening if you run a query like this? Let's actually go to Compass, and we say I'm connected to Oracle and I am running a Mongo query brand equal apples. So what's happening is that the Mongo API will actually translate this query statement to an equivalent SQL statement. So the database, it's a relational database, and that sees a SQL statement, select from my products table where my data column has a field brand and its value being apple. So these entire NoSQL APIs, be it Soda or be it the Mongo APIs, these are convenience layers on top of the database to take these NoSQL operations and transform them to equivalent SQL operations. So the database stays a full SQL database. It means the optimizer can pick the best plans if you have indexes, materialized views. If you select from multiple collections or tables, it knows the right order of joining these things. So it's really more a convenience function for a person that prefers a NoSQL API to the data. It's not that the database is put into a Mongo node or that there is some Mongo code in the database, not at all. It's really like a rewrite layer. So what is the roadmap for implementing other Mongo syntax, for example, the aggregation pipeline? Yeah, we can't commit to any deadlines there where we say by this month it'll be done. I personally believe it will be incremental, that we will add capabilities as we go. So we also want to learn from users what they feel is most important and prioritize development based on that. The good thing is that there is always SQL, and we have a very, very powerful analytical operations in SQL, but we also understand that for existing applications that make use of the aggregation pipeline, it's a lot of work to rewrite that to SQL. So it would be better if we support it more in the aggregation pipeline. So this is why we work on it. Stay tuned would be my answer. Other restrictions, how many levels of nested group bys we can have on JSON data. It's the same. If there are limitations, I would not know them. They would be the same limitations as the Oracle database has. So the JSON processing is deeply integrated with the kernel core, or with the code of the kernel. So it's a regular group by or order by or having clause. So there is nothing JSON specific that would limit the nesting. And our JSONs, we have like a binary data type called OCI, and that actually has, in terms of nesting limits or size limits, etc., it allows more than MongoDB's BSON format. So also from a data migration point of view, you're kind of going to a richer data representation. And it's also a binary format that is very efficient to query. And it also allows for piecewise updates. So that's another topic here, really. But yeah. Okay. Then no more questions. Then
one just came in.
Oh, just came in. Can we create stored JavaScript functions in Oracle Autonomous and execute them from JSON queries like we would expect PL SQL from? Kind of, yes, I think so. We now have, do you know in what version is it available, like GraalVM, and it's 21, right, Roger? So we do have, we have very strong support for JSON and PL SQL. So there is a JSON JSON functions, JSON built-in types to work with JSON and PL SQL. And there is another component which is called the GraalVM or multi-language engine, and that supports JavaScript directly in the database. I don't know, I have to admit, I don't know if it's already available in 19C. I doubt it a bit, but it's certainly coming.
Yeah.
Yeah. So you could look at, take a look at the 21C database. Yeah. Okay.
I think that's it.
Okay.
Excellent. Thank you so much, you two. Thank you, Roger. Thank you, Beda, for coming in and sharing your expertise with us. We hope that folks will come back and join us for future sessions. And thank you both so much for this presentation. Thank you to our audience, and I hope everyone has an excellent rest of your day.